students, welcome to this section. We have a problem on the board. We want to resolve the expression 1 minus 2x divided by x squared plus 1 into x squared plus 3x minus 2. Now, you'll notice vividly that the denominators are all quadratic functions, but we cannot factorize. We cannot factorize this, we can also not factorize this. So in resolving, we are simply going to be using ax plus b for the first case, which is x squared plus 1, plus cx plus d, continuation of b, cx plus d, all over x squared plus 3x minus 2. So this is how to resolve the quadratic function when it is not factorizable. So at the end of it all, we are going to have, I want to neglect this part of it, so I'm going to have LCM of the denominators to be x squared plus 1 and x squared plus 3x minus 2. So that the first one, this cancels this, so I'll be left with ax plus b into x squared plus 3x minus 2 plus cx plus d into, this cancels this, we are left with this, so we have x squared plus 1. And then on this side, we have our 1 minus 2x. So what we simply do is to expand. So 1 minus 2x will be equal to, we expand this times this. So we have a x cubed plus 3ax squared minus 2ax plus bx squared plus 3bx minus 2b plus cx cubed plus cx plus dx squared plus d. So we collect like terms. Once with the third power raised to power 3 x squared, we have a. So let's begin. We have a raised to power 3. We have c. So a plus c. Nothing else again. On the left hand side, we have none. So we have equals 0. This makes equation 1. The ones with x squared, second power raised to power 2, we have 3a. So we select 3a plus b plus d equal to, on the left hand side we have none, so 0, that makes equation 2. Then the ones with x, we have minus 2a plus 3b plus c equal to, on the left hand side we have minus 2. So that makes equation 3. And then the constants we have minus 2b plus d, minus 2b plus d to be equal to, constant on this side is 1. So that makes equation 4. So we shall be solving each of these equations simultaneously to obtain the values of a, b, c, and d. So let's get started. We can begin with equation 1. So from equation 1, we could say A is equal to minus C. So from equation 1, A is equal to minus C. We call this equation 5. So we substitute the place of A into equation 2 and 3. Into equation 2 and 3, that will simply give us in place of A, we are using minus C. So we have 3A, 3 into minus C plus B plus D plus B plus D equals 0. So that will be called equation 6. On equation 3, when I put minus C into this, it's going to be minus 2 into minus C, which makes 2C. So I'm going to be getting 2C plus 3B plus C plus 3B plus C, that is equal to minus 2. This makes equation 7. At this point, I can simplify straight from here. 3 times minus C will simply give us minus 3C. So I'm going to be having minus 3C plus B plus D equals 0. While on this side, I'm going to be having two C plus C, which makes 3C. So I'm terminating this, then making this 3. So 3C plus 3B equals minus 2. Simplify. And then we also have minus 2B plus D. Minus 2B plus D equals 1. Equals 1 from equation 4. So the equation reduces to 3 equations. CBD, CBBD. So what we simply do is, I'm going to make D the subject of formula from equation 4. So from equation 4, I could say D is equal to 1 plus 2B. This makes equation 8. So I'm going to substitute, put equation 8 into equation 6. Into equation 6 so that I can have a simplified form of C and B. So into equation 6, I'm having minus 3C plus B plus D. D in this case now will take the place of 1 plus 2B. 1 plus 2B is taking the place of D equals 0. So that will simplify to give us minus 3C plus 3B to be equal to minus 1. This makes equation 9. At the end of the day, I have something common from equation 7 and equation 9, which I'm going to solve simultaneously. So I want to bring down equation 7 and 9. So from equation 7 says 3C plus 3B is equal to minus 2. This is equation 7. And then equation 9 says minus 3C plus 3B equals minus 1. Equation 9. So looking at the format of the equation, I'm simply going to add. I'll add equation 7 and equation 9. I'm going to add both equations. So I'm introducing a plus here. Adding both equations simply terminates C. So I'm going to be having 3B plus 3B, which makes 6B to be equal to minus 2 minus 1 gives me minus 3. At the end of the day, divide 2 by 6. 6 terminates, 3 is 1, 2 here. So we have b to be equal to minus 1 over 2. Value for b obtained. Looking at equation 8, we can find the value of d. Since we have obtained b to be minus 1 over 2, we can find d. So from equation 4, we are told that d is 1 plus 2b. So let's substitute. D will be 1 plus 2 into b is minus 1 over 2, of which terminates this. So at the end of the day, I'm going to be having 1 minus 1, which automatically is 0. So we have obtained d to be 0. We have d, we have b. Left is a and c. Because from equation 1, we know that a is equal to minus c. So we need a relationship that will connect b and d. So let's look at equation 9. From equation 9, we have it that minus 3c plus 3b. From equation 9, we have it that minus 3c plus 3b is equal to minus 1. Since we have b to be minus 1 over 2, so minus 3c plus 3 into minus 1 over 2 is equal to minus 1. So we have minus 3c to be equal to, let's say minus 3 over 2 is equal to minus 1. So let's cross over. We have minus 3c to be equal to minus 1 plus 3 over 2. We take the LCM. Taking the LCM, on this side gives us 2 here. Better still, we take the LCM of 2. So LCM is 2. So 2 times minus 3c gives us minus 6c to be equal to, this is minus 2 plus 3, which makes minus 6c to be equal to 1. So at the end of the day, c will be equal to minus 1 over 6. We've been able to obtain the value of c. Once we've done that, it means that a can be obtained from equation 4 rather. A is equal to minus c, which means a is the negative of negative 6, which makes a to be equal to positive 1 over 6. So from one equation, it leads to the other, and it makes the job done easily. So we have A, we have B, C, and D. And then all we simply do is to come to the equation and then substitute. In place of A, we fix in the values for A, B, C, and D. And that gives us the resolved form of the partial equation, considering the denominator to have a quadratic expression. I'm sure this video is clear to us. Do well to drop your questions where and when necessary. See you for more videos. Have a nice day.